we will create a Python Pulsar function using cursor and then deploy it to a cluster using the StreamNative MCP server. By using a cursor rules file, cursor will guide us through this creation process, packaging the function, deploying the function, and even testing it. And with StreamNative Agent Engine, this Pulsar Python function could even be used as a tool. So using this method, you could even write any Python code that can be executed by agents. So to get started, I'm running the MCP server locally here. I've already downloaded it. I'm just going to go ahead and execute the command to start that server. And then once it's started, I'm going to go ahead and hop on into Cursor and show how I can then connect to this MCP server. It said failed to create Pulsar Function Manager. I'm not trying to expose any functions as tools to Cursor, so I didn't enable that feature, or I didn't specify an instance and cluster to be able to do that, but it says my MCP server is now listening on that port. Here in Cursor, I've already set up the MCP server. Let me show where that setup is. So if I go to Cursor Settings, and I go to MCP, let me go ahead and disable and re-enable it. And it says it's linked up and it has a list of tools. If I go into the Edit Delete, you can see this is all I had to do to set up Cursor to be able to see that local MCP server listening on that port. And again, if I disable and re-enable it, it would actually get the tool list. So this is the current set of tools that I'm able to access through MCP. I have a GitHub repo here. I've actually cloned the entire Pulsar GitHub repo because it has some Pulsar functions, Python examples here. These are all simple single file Python functions. We're going to create one that's a little bit more complicated where you actually have to import a library. We're going to use an API call, so it's going to import requests. And to help us with the creation of that function and the packaging of it, because once you have a requirements file, you need to zip it up in a certain form. And then we're going to deploy it and test it. To help with that process, I've created a cursor rules file. And you can contact StreamNative Training to get the latest cursor rules file. But I created this one. And it's going to go through a 4-step process. So it's basically going to guide us through the creation, the compression, the deployment, and the testing. And then I have details of what it needs to know for each of those steps to help it along. I suggest reading through this if you ask for this file. Hopefully the LLM will be able to follow all of these requirements. I might need to be a little bit more stern on some of them to force it, but it's going to basically try and help us through these steps. So the prompt I'm going to use for this entire process, here I'm going to put in the left, and let's just read through it. It's just create a new Python Pulsar function called myWeatherFunction, put it in Pulsar Functions Python examples folder. It takes a city as a string from the topic called weather input, and using a free API from Open Weather Map, output to the topic weather output. I'll edit the Python code to include the API key. So it's basically, I'm telling it that it doesn't need to do the API key yet. Sometimes it tries to import it from an environment variable, but in this case, I'm just going to hard code it in. And let's go ahead and execute this in a brand new chat. So there's no history here. And let's see if it can pick up the cursor rules file and is able to help us through this. So first it comes with a plan. And let's read through this plan based on what the cursor rules file is. It's going to create a new folder called myWeatherFunction with these folders. So a dependencies folder, a source folder where the Python is, and the requirements file for the dependencies. The function is going to call a city, or receive a city name, call the weather API, and output a summary. And then it's going to leave the API key. It's going to put requests in the requirements text. So again, I didn't say it needed requests. It figured that out and then decided to make the requirements.txt file. And then it's not going to deploy or zip, because in my cursor rules file, I said, let's wait. Don't start going through all the steps. We're going to guide you through, or we're going to say when we're ready to move on to the next step. Yes, this plan sounds good to me. Before I execute that, let's hop back in that Python function, or Pulsar Functions Python examples. You'll see there's no folders in here. So it's going to go ahead and start making that folder structure for me, because that's where I asked it to place it. So it made the myWeatherFunction folder, made the requirements.txt file, made a source folder with Python code here, which we're going to accept in a second, and a dependencies folder. So from the requirements, I'm going to go ahead and accept that. From the myWeather function Python, I'm going to accept it, and then I'm going to paste in my API key here. So all I did was paste in that API key. I closed it out so you can't see it. And it says, let me know when you're ready to proceed with zipping the function. So I'll say, let's move on to the next step. Now in the dependencies folder, there was a git keep file. I'm going to leave that in there. It may fail. I haven't tested by leaving it in there. I think in the cursor rules file, it says don't leave it in there, but we'll see if it's able to deploy it correctly on the server. So it's going to zip up the file, use the correct name. It's going to include the myWeather function folder. So it's not good enough to just put the dependency source and text file into a zip file. It actually needs that base folder inside the zip file. Actually it says do not include the git keep or any other extra files. So while it keeps it here in the GitHub repo, so if you were to save this or send this back to zip or GitHub, the dependencies folder wouldn't get lost, but it does know to zip that up. So it's going to create that zip file. I'll say let's zip it up. I like this plan. We'll test it out. Okay, it's going to ask me to approve that. That looks good to me. So it added that base folder, the requirements, the dependencies, the source, and then the Python file in source. So now it's basically prompting me what cluster tenant namespace do I want. That's because in my cursor rules file, I've actually told it to kind of prompt me along with this process. Well, I'll say what clusters do I have? This chat wouldn't know that yet because it actually hasn't talked to the server. So now we're using the StreamNative MCP server for the first time. I'm going to say what are the available clusters. It's going to return a list of clusters. I want it to use, I just spun up the test cluster for this. I'll say let's use test cluster. And then it should set the context. Actually, it's going to try and run the tenant. So then it's going to have to set the context. It's going to realize that always has to do that step after you choose a cluster. Since I say I want to use certain tenants and namespaces, or what tenant namespace, it's going to list them for me. So it's being a little proactive here. I'll say let's use public. And then because I've chosen a tenant, it might also automatically want to check namespaces in that tenant because of the cursor rules file. And I'll say let's use default. And then it wants to already execute the create command here. It's going to use this name in this tenant namespace. In the Pulsar or in the cursor rules file, I've told it to use the full path of Python for the Python file to the zip file. And that is needed by the MCP server, and that does a great job. The class name, it knows to not put source dot. Sometimes it tries to do that without the rules file, but here it just uses the class name, and then this is the name of the actual class. If you go ahead and look inside of there, inside of your myWeather function.py, and then my input, I told it, and my output, I told it what I wanted to use. So we'll go ahead and run that. That actually looks good to me. So a lot of the filling in of that correctly, of course, is because the cursor rules file. So it says has been successfully deployed because it ran that MCP server command to create it. It's kind of prompting me to check the status or to test it because the cursor rules file knows that that's the next step. I like to check the status of the function. And if the function isn't, if it's in like a failback or a crash loop, it will actually be able to check the server for errors in the logs. So let's see. Number of instances, the function is running, no errors or restarts. So we're good. Again, if you do have errors or restarts, I would next say check the logs, and it might tell you why it's failing. But I've tried to make the cursor rules file as helpful as possible so that a lot of the common problems related to the zip file structure are always going to work out for you using that cursor rules file. So I'll say let's test out the function. So this is already step 4 out of the 4 steps. The first step was create it. The second was to zip it up. The third was to deploy it. And then the fourth is now to test it. It's probably going to come up with its own plan here of how to test out the function. So it's going to know that it needs a string input as a city. The output it'll then try and create a subscription on that output topic. So here's how we'll test. Produce a test message to the input topic. We'll maybe use London and then consume the result to verify the function's output. So it actually is already trying to write London to the input topic. And once it does that, we'll run a consumer. It should have a subscription here. Yep, so it's test sub, just trying to consume one message. If you know how Pulsar works, there's no message retention policy. So we produce the message before we had a subscription. So there's always the small chance that message gets lost. In the cursor rules file, I actually have a suggestion to try multiple messages once we've actually created the subscription name, and then everything typically would work out. So I like to get the subscription in place when I test myself, but let's see what it says. And it says London was sent to the successfully, no message was received. So we'll send another message. I like to try a couple messages the first time I test something out. And it's going to try and consume. And if we take a look, it's going to use that same subscription. And also it used latest and not earliest. So that's the first time it also used latest. So that's probably why it missed it. So success weather in London, few clouds, 30.17. So we know actually that the function's working. We got the weather back. The other problems that you could run into are not that the actual function is failing, but there could be issues with the actual Python code or the API key isn't working, and you'll get different errors back then. And then that's something you'd have to troubleshoot to figure out why. But in this case, it looks great. So with a good cursor rules file, we're actually able to create the function. We're able to zip it up with the correct folder structure. It does a great job. We're able to deploy it, and we're able to test it. And you would be able to troubleshoot it as well. If you would just say something like, is there anything interesting in the function logs? And then one really cool thing about functions is, in addition to be able to use them in a streaming manner, they're actually callable by the agent engine. So we would be able to say, if you needed to run a function for a specific reason, because you can attach descriptions to your functions, they can be exposed as tools through an MCP server in an agent, and that would be running in StreamNative Agent Engine. And it's really cool then. You could write Python code that the agent would know that that Python code is what I need to call. It would produce a message and consume the result, and then use that result in the agent. You can actually clean everything up right here too. You can say delete the function, and it would delete it. You could also say, so here's delete. You could also do deletions of the topics. You can do deletions of namespaces and tenants. In this case, we use public default, but it's actually very, very powerful of what you could do with the StreamNative MCP server and using the cursor rules file to create your functions.